Hello everyone, and welcome to our run-through and introduction of the DicomAnalyzer software. My name is Dr. Kuhn. I will be guiding you through this process because I created the program. So what we have here at first is we've opened our three images. We've got the pre-lateral, the pre-nasium, and the pre-vertex. As you will notice, they are very big and very white because they are coming in as raw dicoms, and so they are very large files. In terms of moving around on your image, you'll be able to use the mouse for all your features. Your left click is what you use to left click. It's how you click and select and pick your points and do everything else. Your right click will allow you to right click and drag to the right or left to change the brightness and contrast of the image, or up and down. So if I zoom out a bit here, and the zooming out and panning happens with your mouse wheel. So when you roll the mouse wheel back, it zooms out. When you roll it forward, it zooms in. If you click the mouse wheel down and move your mouse around, you'll be able to pan around in the image. So this gives you a dynamic means of looking at your image through all the process. Now I want to get these looking really pretty so that when we analyze them, we're good. Going up gives you a higher contrast. Going to the right gives you darker. Left gives you brighter. Down gives you lower contrast, so you'll get more gray. And so you can kind of set the films to where they look really nice and you're able to see your places well. You don't have to lock in at that. You can change that as you're doing your analysis. So all of your mouse controls are able to be done at any point, anytime, while you're in an analysis point or while you're not. So we'll do the same thing with our other two films. Drag up and to the right is the most common way to get an image better. There. And then lastly on our vertex. There. Now we have some images we can analyze. If you notice your right markers on the right here, in the vertex, we've got, or in the nasium, sorry, we've got a left marker down here on the left, and the lateral left markers on the left. If for any of these you had that wrong or confused, there is a mirror button up here at the top. You can flip that image back and forth. I find this to be a very effective tool for checking if you've taken your image properly. So when you get this image on here and you start flipping it back and forth, this one's not exactly centered to the center of the image, but you're looking for, like, is the head turning or rotating as you're doing that? And then just make sure that when you're finished that you still have it marked appropriately. This will be lit up in yellow when you have flipped it. So if you don't have a marker, you've forgotten it, and you know the image is right, that'll tell you whether you're in a mirrored or not mirrored position. And then on the lateral, we're doing the same thing. Got a nice line down the center here to check, so you can check it that way as well. The other tools we've got up here is the invert function, which when these are very bright and dark doesn't show up, but it can show you in white to black instead of black to white. It just reverses the position. When you have this program on your own computer and you want to use it and you have consistent images that are coming in to analyze, you don't have to do the setting of the image every time. You can use your set default film settings, and then what the program will do is it will bring in the images that you have and apply the level of brightness and contrast that you've set it to. So if you have your own system that you're using, that you get consistent images off of, you can change it to where you get them looking just the way you want, set your default film settings, and then it will show up that way. Other indicators we've got up here is you can include the odontoid measurement. This is an older measurement that was used in NUCA analysis that is not typically used anymore. So you can include it or not if you like. You can use your lateral masses for atlas rotation. I will show you what that looks like. And then this button allows you to turn on or off patient information. I had these preloaded up because the patient information shows up by default. We did not want that to happen for a video that's going out on the internet, so I have it turned off. So if you're ever presenting or anything like that using this software, you're able to do that and then still maintain your HIPAA compliance. In terms of the analysis buttons, there's the APL, which does your Atlas plane line. This tool also requires you to do the Atlas check line. So if we go in here and we zoom in on our Atlas, we can pick our APL. We can choose a point on the left here. We can choose a point on the right. And then it says to select the 2 points for the Atlas check line. So up here at the top of the image, you'll notice that it always directs you in what you need to do. So if you ever get confused or you've forgotten how to do your analysis, this gives you some indicators and pointers as to where to be and what to do next. So there's our 2 points. If we go to our Nasium, this is your output box that shows you all of the information that you have measured so far on the image in terms of what it can display. And so what we've got right now is we've got a convergence of our APL and ACL by 0.5 degrees to the left, which is a little higher than I would like, but is not too bad. And I think it's because this ACL point is a little high and it should be down just slightly lower. If I want to correct that, there's no way to pick that point and move it. What you would do is you'd hit your APL function again and just redraw it. And then I'm down to 0.2 degrees. That for me is a reasonable amount, so I'm happy there. Normally, within most softwares, the function will, if you use other softwares, it will show as green if you're within a ½ degree. And by NUCA protocols, that's pretty close to where you should be. Unless, of course, the Atlas arch is different one side to the other, which can happen. But this is an indicator you can check. The next measurement I tend to do is, or you can follow through, is you can do your central skull line. This one is the most complicated one, so I'm going to leave it till the end. If we do your lower angle, that takes you through all the steps to do the cervical line on the film. And so you'll come out and you'll look at the art or the surface here of C2 coming all the way out to the side. You will look at where this one comes up, and I'll try and, this is a little flattened right here, but I'm going to try and pick a point of where those two would meet. And then as we come out to this side, we're going to do the same thing. This one is a little more difficult to make out because it gets a little fuzzy out here, but I think we're going to be, it shouldn't be that far out because the edge of the Atlas is here. So that's another indicator you can look at, is where the edge of your Atlas is. So I'm going to say this one's right about there. This will give you a body center point. Generally that should hit right on or very, very close to this gray line here, which is the bisecting line of your Atlas. So it gives you a visual so you can see where the Atlas sits compared to everything else. Now when I'm analyzing films, we can do these one at a time, but you can also grab this tab and you can drag it off to the side and then analyze them side by side. And you'll notice this is still in the analysis on the Nasium, but I wanted to look at this and say, okay, I think right there is my spinous for my vertex. I want to check it over here as well. So I can stop in the middle of doing that, come over here, choose my vertex film. I'm going to do the rotation, which is the Atlas rotation on the vertex. The default is that it's going to give you the foramen. And so you'll pick one side and you'll pick 3 points that make the circle. If at any point you don't like a point you've picked, you'll use the backspace and it will unselect that point and allow you to repick it. And you can do that until you've completed a circle. Once you've done that, or completed any function where it's drawn the line, once you've done that, your only option is to close it and redo it. So let's say I didn't like that circle. If you want to leave a command at any point and not finish it, you press the escape button, and that takes you right out. What we're going to do is I'm going to bring this up, get that a little brighter, and I see an edge right down here. See the top of the circle right up here. I'm going to bring that out to the other side, and that should be one side. Other side, same thing. I usually look for the clearest section I can find. It gets a little fuzzy in through this area. And so I might pick this one, that one, and then bring this out to where it's happy as well. And then you're just going to want to compare, okay, does my bisecting line split the atlas when it comes to the top and the back of the atlas? Where does it hit the dens? That doesn't always have to be centered, but it should be consistent between your nasium and your vertex in almost all cases. And then you're going to look at where your foramen sits in the transverse process of the atlas, like this distance towards the back of it, that one towards the front, and just make sure that you're getting a nice consistent position. When I look down at C2, the standard NUCA protocol, if you're using tools, is going to be to use the relatoscope, and it's got a little V shape on here, but you set that V into these two spots right here, where the inferior outlet of the vertebral canal, or the spinal canal, is on C2. Now when I'm marking this, I don't have the V system put in there, so what I'll often use is my S-line tool, and when I click that, it allows me to pick 2 points, and it just throws a line all the way across. So it gives you a nice visual in terms of what this structure is doing, whether the atlas is rotated one way, if the C2 is lined up with it, if they're converging on one side or the other, counter-rotated, all of that. And so what I'm seeing here is that C2 is rotated so that the spinous would be left, and it's rotated by, I don't know, a degree, 2 degrees, 3 degrees, somewhere in there. So I'm looking at this, and I know it's going to be off to that left side, so it's probably that section I was seeing there. If you want to confirm where it's at, when you do your lateral and do your S-line, we can come through here, and we're going to pick that anterior third, and it's going to draw your S-line through. I find this useful because you can see that angle, and then if you wanted to get a good visual idea of where things are at, this right here is your superior articulating facet of C2. And so the lateral aspect of that is where you marked your body center, and if that line comes out fairly parallel to your S-line, you can get a visual of between the body center and your atlas where that spinous should be. And so we're expecting it to be 1/4 to 1/3 of the way up. So now when we go to here, this whole distance, this is your atlas line, this is where your body center line is. I'm off to the left. That right there is the top of it. Right in here I would say is the bottom, and so I'm going to pick that point right there as my body center rotation. And so you can see how you can correlate across all the films. Now when you roll down and go to the bottom, we're picking the lowest cervical vertebra for the fixed point. Old units were that you'd try and find the little white circles in here, is how it was taught in the book. What they've currently changed it to is that you're just going to use the ends of the lateral mass, because that basically agrees all the time. And as long as that hits the center of your spinuses, then you're pretty good. If you need to correct for a rotated spinous down here, what you would do is you'd redo this tool. You'd say, yes, I want to use the existing body center points that I chose. You can click and drag to get that spinous point right on where it was before. And then what you would do is you would click the point where these cross as your center point of the body, and then you would pick the point that is the center point of the spinuses. So if the spinuses were rotated over here, you'd click over there and it would bisect that to give you the center of the foramen. On this case, we don't have to. Control Z allows me to undo whatever my last command was. Control Y, and these are standard Windows controls, will let you redo it. And that'll come in handy when we start looking at the central skull line. So we've done that portion. Next, I would typically do my C over A. When you've done that, you've already picked your body center points, so you can say, yes, I agree with that. You come in here and you follow that path all the way up until you start seeing where that dip is, right beside the dens, which is right there. And you want to come to the medial aspect of the superior articulating facet and click that point. The program will drop down a 3/32 line for you. You do the same thing on this side, and then you're just going to pick a circle that matches those so that you end up with a good axial circle. For the condylar circle, I'll normally pick the lateral aspect of one condyle, the lateral aspect of the other, and then as long as you haven't hit those exactly across from each other, if you happen to, this circle won't show up. just backspace and choose a spot that is slightly different from where it's at. And then you'll just bring that arch down until or that circle down until it nicely matches, especially the lateral third of the condyles. And then what we can see is we've got a condylar circle of 2.7, I've got an axial circle of 6.5, and I'm able to start seeing some of the numbers, because a lot of the numbers of like body center and spinous rotation are based off the size of the axial circle. Now when I come up here and do my central skull line, here's where it will differ a bit from what you learn in the book and what you would use with tools as well as most other softwares. Most other softwares will bring in the cephalometer for you. I don't do that because the cephalometer is a tool that is designed to do a mathematical analysis of a graphical system. Computers are very good at that, and so I make the computer do most of the work. So with the central skull line tool on here, we would click it. It says define the left side of the skull to be analyzed. Spacebar will double click the last point when done. And so what I'll do is I'll zoom in here on the lowest part of the skull that kind of makes a nice line, and I'll start clicking the edge of the skull. And this creates a dynamic line called a spline or an S-line. And you can see it changes as I move my cursor. And so it makes a consistent curve that's mathematical so that the computer can really calculate where the intersects are. Now obviously this isn't the edge of the skull. I've picked some wrong points. So I backspace through and I repick them. Now if you start below your sutures, which you don't have to, normally you're going to be analyzing above the sutures, but in some cases you're going to get a weird skull, and so I always prefer to draw as much of the skull with this as I can, so that if you get one of those strange skulls, you accommodate for it. Now you'll notice I didn't jam all the way back and into that slot. I just kind of try and make that transition as smooth and as close to the edge of the skull as possible. And so we'll pick all those points. You'll notice I can zoom way in and I can kind of fine tune and pick them as I go. You want to be as close as possible to having this line be exactly along the edge. If you do this poorly, you are going to get a poor skull line coming out because the computer does not have a lot of give once it does the work. Now I pick the other side. I'll start out somewhere down here and just bring this all the way up and along. This is the really exciting part of doing this analysis. Now on this one it's a much steeper drop, so I'm just going to kind of bring it right in. There. And then continue on. And generally we're going to either want to analyze widely across that area or not at all using that area, because that's obviously a place where we're not actually looking at the edge of the skull, we're looking at wherever we drew that connection across. I double click the last one, now it's done. Now it says I can change the angle of the tool as desired for preliminary fit with the left or right arrows to press space when finished. So if I zoom back out, what I'm seeing here is my version of the cephalometer. Now what you'll note on here is that there are two horizontal blue lines. Those are 1/4 inch apart, and they are showing you what the zone of the skull that you're looking at. Now if I tilt this with the right arrow, it goes a 1/2 degree every time, and you'll notice that there's a bisecting perpendicular blue line in that system as well. That operates like the central slot in your cephalometer, or that central vertical line on your cephalometer. So that you want to kind of set to where you suspect the center of the skull is going to end up. And then what you'll notice is that there's a red line that moves and changes as I'm going. That is the analysis of the skull over that 1/4 section in live time. And so what we want to do is we want to get to where that blue line kind of hits through our central features. And so I'm looking down at the bottom here, at where the glabella bar is, or the glabella BB, and then also through the central nasal features and across the orbits of the eyes right about here. And so when I come up, I want to see, okay, does that blue line kind of split all of those? And it does a pretty good job right there. And so then when I want to do my analysis, I'm going to say this is a good angle. So I hit my space bar and that locks in that angle as your default starting point. Now it'll say to slide the analysis tool down to the lowest consistent point, and then up to the high, and click, and then up to the highest consistent point and click again to determine the analysis range. Here's where you're choosing the section of the skull you are going to analyze. And so if you'll notice, if I go down through where that section is that I cross the sutures, that line kicks to the left, and that's not an area we would like to include because it's going to change our numbers and throw things off. Down below the sutures, it is kicking slightly to the right. Up above the sutures, it is pretty close to aligning with it. And so you want to get a feel for what your skull is doing over the entire section. You don't want to just find a spot where it agrees and then click it right there and have a very narrow range, because that won't give you a really consistent and reliable skull line. What you want to do is go to the largest range you can possibly do and still have something that works. And so I'm going to bring this up. It starts to kick in a little bit there. I'm probably going to use to about there, because after this the skull starts to turn and it really starts to kick off. So I'm going to analyze up to about here. And what I've got is this does then a perfect double pivot point system over this range in terms of where the X's are drawn. And so that way, when you're doing your post X-ray or reanalyzing or looking at somebody else's images, you can see the part of the skull that was analyzed. If you reproduce that, you'll notice we have a 2-degree laterality, 0.1 degrees of left head tilt. If I reproduce this, even if I change the angle a little bit the other way, so it's wrong, if I pick that same range, we're going to get the exact same numbers. And so there's a lot of give in there when you use a larger portion of the skull to give you the really consistent same numbers every time. If you can't get the same numbers, it's probably because you marked the edge of the skull poorly, and you might need to go back and redo that. And so then if I was going to redo that, I would just say no when it pops up and says, would I like to use the old left and right skull curves? And then I would have to redraw those. And often if I'm doing that, I'll redraw them out of the way so I can do it once more and draw them cleanly off of a fresh palette. And so like I can even pick the whole skull. So sometimes you get really weird skulls that kick back and forth and you'll just pick the whole thing. And that still works out very, very close to where that is. So this is a system that allows you to analyze the skull pretty easily, pretty quickly, as long as you've done a good job of marking the edge of the skulls. And so that's what we've got there, and basically all our numbers here are done. So we've got a 1.9 degree laterality. If I want to go back to just using the area above there, I've got a 2-degree laterality, so we're within 1/10 of a degree. It's very consistent. I've got 0.1 degrees of head tilt. Looking at my atlas here, we've got a 1.8 degree atlas plane line up on the left. The lower angle is kinked by 3.3 degrees. The angular rotation, which is the angle of this off of vertical, is 1.5 degrees left. This dashed blue line is your vertical line drawn up from your fixed point. So that's kind of the baseline of where everything would line up to. Like I said, you've got your condylar and axial circles, you've got your body center measurement, your spinous measurement, and so we've got a net spinous rotation from where I marked it of 4.3 degrees left. If we wanted to check how well that correlates over here, you can use your Atlas plane line tool over here and mark one, and then the other side, and then pick an Atlas check line anywhere. And what we're seeing is I've got a 3.3 degree rotation of my Atlas plane line. So it's a degree difference in terms of where it's measured here versus here. Some of that is based on how it's factored out and how it's measured. This condylar circle is going to change that. So it's never been a perfect measurement off of the nasium. It's an implied measurement based off of the condylar circle. The other thing that can happen, so if we look back at the vertex, is you may not have your dens and your central features and everything lined up right on the middle of your film to where that's consistent and reliable. This system uses the default of what was the newer way of measuring the vertex, where it was just measured off the vertical of the film, but it requires you to take a perfect film like this one is. If you take a film and things are not on center and you think it's good enough to see your points and you still want to use it, what you can do is you can use that Atlas plane line tool, and then what I'll do is I'll pick the middle connection points on each of these so I can recreate my Atlas check line, and then I will pick from the bisecting line, where that bisecting line, that gray line, so crosses the Atlas, so you've got your center of the Atlas, and then I will draw a line that comes up through the central features or the glabella on the skull. And so if I darken this up, you can see that gray line is your check line. And so if I bring that up and take it right through the glabella, then what you'll notice is that I've got an Asian view where it's converging between the Atlas plane line and the Atlas check line by 0.5 degrees on the left. So this should be 90 if those are perfectly perpendicular. This says it's converging by 89.5 degrees on the left, which means on the left side we are posterior, and on the right side of the Atlas we are anterior by a half degree. And we'd measured 0.8 with that measure, with our other measurement. So this is an excellently taken film. It's definitely within a quarter degree, possibly better in terms of what that measures, but that is a way to accommodate and figure out, okay, how close am I? Is this usable? Is it not? And be able to do the measurements in the original way that it was taught and in the book. I think that covers pretty much everything. There are some outside cases of ways to do things, but this kind of gets you the intro and where to start. Hopefully you find that useful. If anyone needs the program or needs help with it or has troubles where it's crashing or anything else, I am reachable through email is one of the best ways at dr.kuhn@providencenuka.com. And I hope to see all of you at conferences in the future. Thank you and have a great one.